As you can see from the title of this video, this tutorial is about drawing the Lewis structures of polyatomic ions. If we're going to learn how to draw the Lewis structures of polyions, we first have to know what a polyatomic ion is. And by definition, a polyatomic ion is a group of covalently bonded atoms that carry a charge. So the idea behind a polyatomic ion is they will be very similar to our covalently bonded structures. The only difference between them is that your regular covalent bonded structures, I would go to the periodic table and I would simply add up their valence electrons based upon their group. Group 1 gets 1, 2 gets 2, 13 gets 3, 14 gets 4, all the way up to 18 getting 8, and I would be done when I add up my valence electrons. When it comes to doing polyions, there's a little bit more to that, because when something carries a charge, that means it has gained or lost valence electrons. So we have to account for that as we go through and draw our different Lewis structures. So the best way to attack a polyion is to look at what you're working with. Let's say we take a look at something like nitrate. Nitrate has the formula NO3 -1, NO3 -1. If we went through the traditional way of trying to figure out, is this a before and after picture, is this a single picture, you'd see no surprise. Nitrogen falls to the right of the staircase, so does oxygen. That means it's a non-metal, which always tells us it's covalent. The only difference is now we have this -1 charge. If you remember, whenever we were doing normal covalently bonded substances, the idea was we tried to follow some steps. And I'll re-jot a few of those steps right now. Remember, step 1 was draw the skeletal structure. Step 2 was determine valence electrons and make single bonds. Step 3, use remaining electrons to fill octets / duets. And then a small subcategory on step 3 was, if you are short electrons, you create multiple bonds. And if you're heavy, so to speak, on electrons, they go on the center atom. So we'll leave that up there just as a little bit of a reference. Right? In the meantime, we'll come back over here and try to follow those steps. So if I'm going to draw my skeletal structure, usually the one that needs the most electrons goes into the center. So if we took a look at N and O, N is right here, group 15, which means it has 5 valence electrons, which means it needs 1, 2, 3 to get to 8. O is right here. It has 6 valence electrons. It only needs 2. That makes me want to put N in the center. A lot of times you can get a feel for what's in the center because it's the one in least quantity as well. Right? Because there will be times where we have 2 things that have the same number of valence electrons, or occasionally the thing that has more actually goes in the middle. Right? But we can see that N should go in the middle. and I'll put an O on each side. Now I'm going to add up my valence electrons. As I said before, ends in group 15, so that gets us 5, plus oxygen is in group 16, so we get 3 times the 6. And here is where doing polyions gets a bit different. We used to just stop there and get our number. Right? But whenever we have a charge on something, that tells us that something has happened to the valence electrons. If you remember, a negatively charged ion is called an anion. Anions have gained electrons because electrons are negative. If you gain one, you get more negative. So the fact that NO3 is a -1 tells us it has an additional valence electron. So we have to just add one more because of the charge of -1. So if we take a look now, we have 18, 19, and 5 means we have 24 electrons to work with. Next we would draw single bonds. I drew 3 single bonds, which means I ate up 6 valence electrons. So I have 18 electrons left to try to fill the octets of everything else. We always start on the outside and work our way in. So this O needs 6. So 1, 2, 3, 4, 5, 6. I still have 12 left. This O needs 6. 1, 2, 3, 4, 5, 6. This O needs 6. I have 6. So I've used up all my dots. I have 18 dots. Now I need to check to see if everybody is happy, so to speak. So this O here, 2, 4, 6, 8, it's good. O here, 2, 4, 6, 8, it's good. This O here, 2, 4, 6, 8, it's good. And now lastly, nitrogen, 2, 4, 6. Nitrogen is not happy. It needs to get to 8 valence, and it only has 6 due to the 3 bonds. So we are out of electrons. I have no more dots. I can't put 2 dots down here. So if we're short electrons, we should create multiple bonds. And remember, to form multiple bonds, all we do is pull them from the outside of one of the atoms, one of the unshared pairs, and push it into the middle, because in the middle, it will get shared for both. So you have 3 options here. You have this O, and this O. You will learn that it doesn't really matter which O you create the double bond from. Right? That it is equally probable that it would happen at any one of them. And we'll learn about that idea later on. It's called resonance. Right? But for now, just realize that you have a double bonded O and 2 single bonded O's. Right? Last but not least, to finish a polyion, you always have to put it in brackets and write the charge outside, because that is what tells everybody that you have an additional electron to work with, because there is no way I can draw this picture without that last valence electron. So that's how we tackle something like nitrate, which is NO3 -1. Let's take a look at another one. We'll slide our rules over here and see if we can do something like ammonium. Ammonium gets the formula NH4 plus 1. Again, if you looked at this and tried to figure out what's going on, you would see that N is a nonmetal and H is obviously hydrogen. Anytime you have hydrogen with a nonmetal, it's covalent. So, we'll follow our steps. Draw a skeletal structure. N gets 5 dots, which means it needs 3. H has 1 dot, which means it needs 1 because it's only trying to get to 2. So we put N in the middle. And we will surround it by H's. Next, we'll add up our valence electrons. N gives me 5. And I have 4 H's that will each give me 1. And now I have a charge of plus 1, and it's the opposite of what we just did with nitrate. A positive charge is called a cation. Cations are created by losing electrons. Electrons get lost, they are negative. That leads to a positive charge remaining. So if this is a +1, it actually means we have one less valence electron to work with than we thought. So, looks like I have 5, 9 minus 1, I have 8 valence electrons to work with. We then make our single bonds, 1, 2, 3, 4 single bonds. Each one costs us 2 electrons, so that means I have no valence electrons left to work with. So hopefully we filled the octets and duets, otherwise we'll have to create some multiple bonds. So let's take a look. Hydrogen's supposed to have 2, single bond is good. 2, good there. 2, good there. 2, good there. Lastly, nitrogen needs to have 8. 2, 4, 6, 8 for the 4 single bonds. Tells me that we have a good structure here for ammonia. To make it complete though, you have to put it in brackets and write the charge outside, which would make it be a +1. Slide that to the side. Let's look at another one. How about something like sulfate? Sulfate with an ATE ending gets the formula SO4 -2. Again, you'll start to see a pattern emerging because we're all doing polyions. I see non-metal, non-metal. That means that I'm going to have to draw one picture, not a before and after. If we take a look to decide for our skeletal structure, who goes in the middle, both sulfur and oxygen have 6 valence electrons and need 2. So how do we decide what goes in the middle? You have to do it kind of logically. If I have 1 S and 4 O's, usually the thing that is by itself will go into the center. So we will put S in the middle and then put an O on each side. Next we add up our valence electrons. As I said, sulfur is in group 16, so we get 6. Oxygen, there are 4 of them, and that is also in group 16, so we get 6. And now a -2 charge means that I have had 2 electrons gained, which means I need to add 2 valence electrons. So it looks like we have 24 plus 6, which is 30, and 2 more is 32. Then we make our single bonds. Okay, 4 single bonds uses up 8 of our valence electrons, leaving us with 24. Okay, so we have 24 dots to try to make all of the atoms happy. Right, this O here would need 6, so 1, 2, 3, 4, 5, 6. As with this one, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So I have used up all of my dots, right, and now I better have filled my octets or I'll have to create multiple bonds. Taking a look, right, O is supposed to have 8. I have 8 here, 2 in the single bond, 3 unshared pairs. Same here, same here, same here. And lastly, don't forget to check the center atom. Sulfur needs 8, 2, 4, 6, 8. We have a good structure here. So we have to put it in parentheses and put the -2 charge outside. Moving on, let's try, say, 2 more. Let's take a look at something like the polyion phosphate. Right. Phosphate gets the formula PO4 -3. So we draw our skeletal structure. Phosphorus is in group 15. It has 5, so it needs 3. Oxygen, group 16. It has 6, so it only needs 2. So we'll put a phosphorus in the middle. surrounded by O's. Add up our valence electrons. Phosphorus gives us 5. 4 times oxygen, which is 6, and plus 3 more due to the -3 charge. So again, looks like we have 24 plus 8, which will be 32. Make our single bonds. 2, 4, 6, 8 electrons got burned up, leaving us with 24. Very similar to the last scenario. Start from the outside in. Each O needs to get 6 dots. And if we do that, that uses up our 24. And then lastly, to check to make sure we filled our octets, right? 8 here, 8 here, 8 here, 8 here, and then phosphorus. 8's all contained in single bonds. So we draw our brackets and put a charge of -3 on the outside. Last but not least, let's try something like carbonate. I'm just going to erase this one up. And carbonate gets the formula CO3 -2. Right, drawing our skeletal structure, we will put carbon in the middle because it needs to gain 4 and the oxygens only need to gain 2. So I put the O's there. Adding up my valence electrons, carbon gives me 4, oxygen gives me 3 times the 6 plus 2 more, which is 18, 20, 24. Draw my single bonds. I have 3 single bonds, which uses up 6, leaving me with 18 valence electrons. So using those 18, we have to fill our octets. This O needs 6, so 1, 2, 3, 4, 5, 6. This one needs 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So I have used up my 18 dots. Right? Check our octets. This O is good. 2, 4, 6, 8. 2, 4, 6, 8. 2, 4, 6, 8. We're good there. And lastly, the carbon, 2, 4, 6. Carbon is not happy. So what has to happen is we need to create multiple bonds. And again, this will lead to something that we call resonance that we'll learn about later. But you can take the 2 electrons from any one of the 3 oxygens. So if I took them from here and made it look like this, that would be correct. But if you decided to take them from here and make it here, that would also be correct. And if a third person took them from here and put it here, that would also be correct. But the moral of the story is you have to have 1 double bond in your structure and 2 single bonds. And lastly, to finish out, I have to put the -2 outside of the brackets. So if you notice, very similar to how we do covalently bonded Lewis structures, a slight adaptation to adding up your valence electrons to get your electron bank, so to speak. And then you always have to remember to put your polyions in parentheses, because what you're going to learn is soon that this structure will have electrons given to it by something. They just don't come from random atoms, and we will look at that later on in the chapter. If you're having any confusion, please feel free to stop in for some help. Otherwise, I hope this helped you out.